First up, we're asked to solve this trig equation, root 3 sine 2x equals cos 2x. The key is to try and convert it into tan 2x, and we can do that by, first of all, I'm going to divide through by root 3. That will give me sine 2x is equal to 1 over root 3 times cos 2x. And now I'm going to divide through by cos 2x, because tan is sine over cos. So tan 2x, that's sine 2x over cos 2x, is going to equal 1 over root 3. You could do it the other way around. You could divide through by cos 2x first. You'd get 1 on the right-hand side, not 0, and then divide by root 3. Same result. Okay, so now we're going to solve for 2x, first of all. Find all the solutions for 2x, and then we'll divide by 2 after. So because x is between 0 and 360, that means that 2x is going to be between 0 and 720. I need to times it through by 2. Right, let's find our solutions. Let's do inverse tan of 1 over root 3. This gives 30 degrees. And then it's just a case of finding all the other solutions. And there's two ways we can do it. Method 1 is going to be to draw the graph of tan x and think about the properties of it. It actually repeats every 180 degrees. So if I get a solution here at 30, then I'm going to get another solution at 180 on 210. So I just need to keep adding 180 on until I am outside of the range, basically. 210 followed by 390 followed by 570 followed by 700. Okay, 750 is outside the range. I can ignore that one. Second way to do it, if you use your cast diagrams, all sausages turn cold, to say, right, I've got my first solution of 30 degrees. It's in the first quadrant. Tan's positive. The next one is going to be here. And so I've got my 30. Then that is also 30. So I need to basically do 180 plus 30. And then I just keep adding on 180 to get the next one, and so on. We're nearly done. Just got to work out x. I can do that by dividing by 2, but it's only at this point I'm dividing by 2. So x is going to equal 15, 105, 195, or 285, all are in degrees. Good job. Quite tricky that. Hopefully you're happy with it. On to part B, where we're given a triangle, 3 sides in terms of x, and an angle. And we're asked to show that x is 5 over 3, and then later on to find the area. So this is going to involve the cosine rule. It's a non-right angled triangle. We don't have like 2 angle side pairs or anything, but we do have 3 sides in terms of x and an angle, perfect for the cosine rule. So I'm going to use this version, c squared equals a squared plus b squared, because that's a nice version of Pythagoras. Well, that is Pythagoras' theorem, minus 2ab cos c. That's the extension. I'm going to relabel it. So this is capital C, and this is C, and this is A. No problem with that. You can alternatively use other versions of the cosine rule. There's 2. The most common being a squared equals b squared plus c squared minus 2bc cos A. You just got to make sure that you're using the angle and the opposite side here and here. So I'm writing it down here. We can say that 4 minus x all squared is going to equal x squared plus x plus 1 squared minus 2 times x plus 1 cos 60. Actually turns out that cos 60 is equal to a half, which makes this a lot nicer because these two cancel out, and now I've got a quadratic equation. Well, let's see what happens. So expanding this bracket, remember it's 4 minus x times 4 minus x. That's going to give me 16 minus 8x plus x squared equals x squared plus, again, a double bracket here, x plus 1 times x plus 1. That'd be x squared plus 2x plus 1 And I'm actually going to be minusing x squared and minusing x. Because it's minus x times x and then minus x times 1. The half and the 2 have already gone. So this minus x squared will cancel with here. And then I can also cancel those out. Go straight for it. So 16 minus 8x is going to equal x. That's a plus 1. Therefore, 9x is equal to 15. X is equal to 15 over 9. Divide top and bottom by 3. Give me our answer of 5 over 3. Brilliant. Okay, it's nice that the algebra just cancels. The complicated bit is, of course, yeah, applying the cosine rule, doing all that, expanding. Hence, find the area of triangle ABC. So now that we've got 5 over 3, we can substitute in for it. I'll put 5 over 3 here. This is going to be 5 over 3 plus 1, which is actually going to be 8 over 3. And then 4 minus 5 over 3. Work out what that is. 7 over 3. Don't necessarily need all of these, but I thought I'd figure them out. So the area, I can use a half AB sine C, 2 sides of the angle in between. So this is going to be the angle that I use. Again, I'm going to use the C that I've labeled. So a half times 5 over 3 times 8 over 3 times sine 60. Okay, let's figure that out. You can use the fraction button, or you can speed things up and just do 5 over 3. Don't need brackets even, divided by, sorry, times 8 divided by 3 times sine 60. This gives us 10 root 3 over 9. That is the exact answer. It doesn't say whether to write it to 3 significant figures, so I'm going to highlight that. I will, however, just write it as 1.92 below. There we go, well done.